Hello, folks. We're going to do some introductory function stuff today. And before I talk about functions, I'm going to talk about a relation. A relation is a set of ordered pairs. Now, some of you might be saying, well, what's an ordered pair? An ordered pair is just like a point on a coordinate plane, all right? You know, whenever you give a point is given as x comma y, right? So a relation is simply a set of ordered pairs. So for example, we could have 2 comma 3, that's 1 point, -5 comma 8, and 6 comma 10. So that is just a set, that's a set of ordered pairs. These are 3 points, 2 comma 3, -5 comma 8, 6 comma 10. All right. And this is what we call set notation. All right. Now, sometimes you will also see table notation, something like this, -3, 4, 2, I'm just making this up as I go, and 2, 4, 8. And you see, this is also a relation because it's a set of ordered pairs. This is -3 comma 4, 2 comma 8, 1 comma 4, 5 comma 2. It's just that instead of writing it with parentheses and commas in between, we just put it in a table. All right. Sometimes, and then the next thing, so you see set notation, you see table notation. Sometimes you will see what's called a mapping. And you could see something like this. 7 goes to 4, 0 goes to 10, 8. This is also a relation because it's a set of ordered pairs. You get 0 comma 10, 7 comma -4, 8 comma 3. All right. So it's just a bunch of ways you can express that. You can also express it with graphs. What I want to talk about is functions right now. Now, functions are, the easiest way to explain it is to probably show you something that's not a function first. Okay, so this is a relation. It's a set of ordered pairs. But you see, a function is a specific machine. It's like a recipe. Like if you have a certain set amount of ingredients and you're making a recipe, you combine those ingredients and you bake your cake and you get this beautiful cake afterwards, and it's going to be the same every single time as long as you do it correctly. So when I have the same ingredients or the same input, I should always get the same consistent output. Okay, so what this is saying here is that the x is my input. Okay, this is my input, and the input is also known as the domain. And then you can guess that this other column is called the output, and it's also known as the range. All right, you've probably heard those terms before. Now, in this particular problem, this is not a function, and let me explain why. It's all because of this -5. You see, this is my input. I put -5 into the machine. Out the other end, I get a 1. That means every time I put a -5 into the machine, I should always see 1 on the other side. Here I put in 6, I got out -2. Here I put in 4, I got out 3. But here you see I'm inputting a -5 again. And that means I should get a 1, but I got a 2. So that's a problem. That means it's not a function. So you're looking for this kind of contradiction. This is what makes it not a function. All right. Now, here's another way, just so you know, f of x, this is how you say this, f of x, that's the same exact thing as y. It's just a different way of expressing it. And what that means is this column is a function of this column. You have to do something to these inputs, and then you get these outputs. Now, here, is this a function? Yes, this is a function. I usually just abbreviate function FCN because there is no contradiction. You see here, -5 goes to 1, -5 goes to 2. That's a problem. Here, all the x values are different. It's automatically a function when you have that situation. And you don't just use f, you can use g of x. Here's another example. Now, sometimes this freaks people out a little bit, but this is a function as well. I know that 7 goes to 3, and I know that 4 goes to 3 as well, but that's okay. It's when the same input goes to different outputs. That's what's the problem. It's okay if different inputs go to the same output. That's not an issue at all. All right? So those are both functions. This is not a function. If you look up at the ones that we had looked at earlier, this would be a function because all the x values are different. Actually, all three of these are functions because the x values are different. Now, something else you're going to be asked to do is you're going to be asked to determine the domain and range. So let's go up. The domain is just the listing of the x values, and you list them in order from lowest to highest. So that's it. Range is the y values, and you go from lowest, which would be -4, to highest. Okay? Now, how I remember that is alphabetically. Domain and range, D comes before R. X and Y, X comes before Y. So the domain and X, they go together. Okay? Range and Y, they go together. Here on this one, our domain clearly is over here. Again, just listing from smallest to greatest. And on the right, now this is interesting. Our range, you don't list repeats more than once. So our range would just be -1, 3. Okay? And the last thing I'm going to show you today is something called, well, we also have, I showed you a set notation, I showed you tables, I showed you mapping. We also have graphs. So like if, here's a function. Well, here's a relation, let's say. And let me just show you some different ones. I'm going to be quick about it. And we'll squeeze one more in right here. And then like this one here. All right. So here, this is something called the vertical line test. Now, picture the graph is this red line, and these arrows mean it goes on forever in each direction. There's an infinite number of x, y coordinate pairs on here, an infinite number. But you see, as we move along this line, x is always changing. X is always changing. So all the x values are different, you see? And it leads to something called the vertical line test. You don't need to write this down, but just if I draw in any vertical line, it's going to cross the red line at most once. And if it only crosses once or even fewer, it's a function. All right? Whoops, I'm not too sure what happened there. But my computer is kind of weird like that. So this passes the vertical line test. It only crosses one time. Any vertical line, it's a function. Here, if we draw a vertical line here, it crosses 2 times. That's a problem. That's not a function. And the reason why is because of the x values. You see here, the x value up here, you see how it lines up with this? Of these 2 points here and here have the same x value. This could be like, if I put a tick mark, this could be 1 comma negative 1, and this could be 1, 2, 3. This could be 1 comma 3. You see here we have the same x value going to different y values. So you see, depending how you move on this curve, x values are used more than once, and they go to different y values. This one is a function. Again, if you draw a vertical line anywhere, it only passes through the red graph 1 time. This is not a function. Look, that crossed 3 times. All right.